Okay guys, here's a follow-up video on SOHCAHTOA. I'll be in class tomorrow. Obviously, I'll be showing you this video. And anyways, I'll probably regret it, but I'm going to be there anyways. Let's get going here. So, SOHCAHTOA. Let's review again real quick. SOHCAHTOA goes: some old hippie caught another hippie tripping over apples. And that helps you remember what sine, cosine, and tangent are all about. But anyways, if we look at this problem number 11, step 1, you always mark your angle. Here's my theta, in our case here. Step 2, you label your sides. Notice I'm missing over here the opposite. I do have the hypotenuse though. That's always the longest side, right? And notice down here, that's the adjacent side. So, since we don't have the opposite, we can only use adjacent with hypotenuse. So, according to SOHCAHTOA, which one is adjacent hypotenuse? And hopefully you saw it right there. Adjacent hypotenuse is cosine. So, we now know that the cosine of that angle theta is the adjacent over the hypotenuse. What do we do next? We're going to go to our calculator, right? We're going to do the cosine inverse. Cosine inverse on both sides. That right there is actually, when cosines cancel out, is my answer. So, of course, I did the calculator work ahead of time. As you can see right here, the cosine inverse. And remember, you press second, then cosine to get the inverse cosine of 28 over 57 is 60.578. We'll round off to the nearest degree. So we'll say theta is 61 degrees. Okay, let's try this one here. First step, we find our missing angle, right? Here's our missing angle. We'll call it theta for consistency's sake. Now we'll label our sides. Notice this time, across from theta, opposite of it is the 29. We're missing this time down here the adjacent side. And we're given right here the hypotenuse. The longest side, guys, is always the hypotenuse. Don't mix it up with the adjacent side. Adjacent's always one of the shorter sides. Okay? But anyways, since we don't have the adjacent given to us, we have to use opposite and hypotenuse. So, if we look at SOHCAHTOA again right here, which one uses opposite hypotenuse? Hopefully, you see the OH right there. That's sine. So I now know that the sine of our theta is the opposite over the hypotenuse. And we're going to again do sine inverse to get rid of sine. So theta is going to equal the sine inverse of whatever that ratio is. Going to our calculator, you can see right here, sine inverse of 29 over 42 is this. Rounding that off, we'll say theta equals 44 degrees. Okay, let's do one more. Here's our theta. Notice the 11 is opposite of the theta angle. We're missing the hypotenuse up here. We're given right here, 14. See how it's right next to theta? That's what we mean by adjacent. So since we don't have the hypotenuse, what uses opposite and adjacent? Hopefully, again, by now you know SOHCAHTOA. And you know right there, OA is tangent. So we know that the tangent of theta has to be the opposite over the adjacent. Again, we're going to do the tangent inverse on both sides. Going to our calculator, Going to our calculator, we can see right here that the tangent inverse of 11 over 14 is this. Rounding that off, theta is 38 degrees. So guys, hopefully that wasn't too bad. And this video, just like the last couple videos I made on SOHCAHTOA, you need to watch them more than once, study them, make notes out of them. Know opposite, adjacent, hypotenuse well. Okay? Know what SOHCAHTOA says, how to spell it correctly. Some old hippie caught another hippie tripping on acid, for example, is a way to help you get it set up spelled correctly. So then you can use sine, cosine, and tangent correctly. So again, I'll see you in class. And hopefully I won't be coughing too much. See you then.